contradiction? What is a proof by contradiction? The idea is you suppose that what you are trying to prove is false. Okay? And then you show this is, and I'm going to use the Latin, reductio ad absurdum, just because I can't say it better than that. Reductio ad absurdum, reduced to absurdity. You show that if it were false, you'd get something totally illogical. Therefore, it's true. So that's the idea of a proof by contradiction. Okay? Sometimes mathematicians don't like proof by contradiction. I love it. I feel like sometimes the best way to show something is true is to show that it's not false. It's kind of the idea. So if we can appreciate what Stephen did here for a moment, let's take a look. Again, the problem said, show there are no 2 by 2 matrices such that this happens. So what did he do? He said, hey, here's 2 by 2 matrices. Let's suppose it equals the identity. Now, he did a heck of a lot of work here because these are variables, because he's trying to show that no matter what these matrices are, and he multiplied it all out, and then he simplified it. He did A times B, he did B times A, he subtracted them. He got a big mess. He turned over his paper, and he said, look, if AB minus BA is going to be the identity, I need the first number to be 1. I need the next number to be 0. And he kept going and working with this, and eventually he worked out -1 equals 1. Well, that's false, right? Reductio ad absurdum. So it must be that his assumption is false. What's the assumption he made? The assumption he made was that AB minus BA is the identity. You see that? Now, there was another nice way to solve it that you could do. You want to pass that back to Stephen? Thanks. So I'm going to use Mike's paper for this one. Mike came for a hint. And the hint in the back of your book said, use the trace. And a couple of you guys did it this way. So I want to show you a little bit. Here's Mike's work. Okay? So, show that no 2 by 2 matrices give you the identity. Well, what he's going to do is a proof by contradiction. Okay? He's going to take the trace of both sides. He knows that the trace of the identity is 2, right? 1 plus 1 is 2. It's a high-powered math class when you can write that, right? It's nice. So now he says, well, the trace of AB minus BA must be 2. Well, now actually we're using some facts that you may or may not know. They were on the group work, and they're also, if you see problem 44 here, so you can split up traces. Traces work really nicely that way. I guess what I'm saying is, if you know that the trace of AB minus BA equals 2, that means the trace of AB minus the trace of BA equals 2. But what is the trace of BA equal to? You have the trace of AB minus the trace of AB would have to equal 2. Right? But that means, as he says here, 0 equals 2. Right? And that's, again, absurdity. So this is a demonstration of what's called proof by contradiction.